Assalamualaikum and hello everyone. Welcome to the video for chapter 4, Introduction to Organic Chemistry for 4.5 Isomerism. In this video, we're going to learn to construct the constitutional isomerism, which is chain, positional and functional group isomers. Okay, so what is meant by isomerism? The name of our subtopic. It is the phenomenon whereby different compound with the same molecular formula but different structural formula. So for our syllabus, the isomers that we're going to learn is only constitutional isomerism. So constitutional isomer is actually the different compound with the same molecular formula but different in the order of arrangement of atoms in the molecules. Okay, so later on we're going to draw, and then I'm going to go back to the definition itself lah, so that it will be clearer to you. Okay, for the constitutional, or the other name for it is structural isomer, we're going to learn is actually divided into three. We have chain, we have positional, and we have functional group isomerism. For the case of chain isomerism, it have the same functional group and the same homologous series, but it differs in the carbon skeleton or carbon chain. Okay, so just add it in your note what is meant by this one. So it means that, okay, each of the isomer will have different longest carbon chain. So what is meant by that? So let us look for the example itself. So for example A, the general formula is C₅H₁. Okay, so for C₅H₁, it's actually an alkane because alkane follows the general formula of CnH2n plus 2. Okay, so how we're going to draw the chain isomerism for the case of C₅H₁? Okay, I'm going to write down the longest carbon chain first. Okay, so for the longest carbon chain, in this case, since carbon, the maximum number that we have here is 4. So the longest carbon chain that we can have at the first place is 4. Okay, so what is meant by this? The longest carbon chain, rantaian, yang panjang, yang berkait. So we have carbon, here it meant the longest one is 4. So I'm just going to draw, we have 4 carbon, 1, 2, 3, 4. So this is meant by the longest carbon chain. Rantaian yang paling panjang is actually 4 carbon. But then this is not the structural formula. Again, carbon needs 4 bond. Okay, so we're going to complete the bond. For each carbon must have 4. And then to complete the structure, we're going to complete the bond by adding hydrogen. So this is the longest carbon chain for C₅H₁. Okay, but then this is not the only way to draw C₅H₁. Okay, the next one, we're going to write down again still the longest carbon chain. So right now, the longest carbon chain cannot be 4 because if I have the longest carbon chain is 4, it's the same as this one. Okay, so the next longest carbon chain is actually the maximum minus 1. So in this case, the maximum is 4, so minus 1, it will be 3. Okay, so what is meant by that? Okay, the longest carbon chain, rantaian yang paling panjang kita, we must have only 3 because here we mentioned about 3. So I'm going to draw 1, 2, 3. Okay, but then we have 4 carbon. Where do we put another one? So if I put it here, carbon here, this one nanti, the longest carbon chain is 4. So cannot lah, this one is not accepted. Okay, if we put it here pun sama juga, we cannot put it here because later on, the longest carbon chain kita 1, 2, 3, 4. So where do you put the carbon? Okay, carbon ni kita letak di tengah-tengah. Because why? When we put it here, still the longest carbon chain kita is still 3. 1, 2, 3. Okay, ataupun kamu nak kira sini. 1, 2, 3. It's still 3, the longest carbon. So this is not the structural formula. Make it complete to have 4 bond each lah for each of the carbon. But I'm just going to make it complete for this one first. Okay, but don't forget this carbon only has 1 bond. So it means it needs 3 more hydrogen. So either you can write down CH3 this way. This is accepted. Or if you want to show all the covalent bond, all the expanded structure, including the CH3 here, is also accepted as well. But then how do we draw it? I'm just going to show it to you. Again, both of these is accepted to draw. The longest carbon chain is 3. Again, so how do we know that it has different longest carbon chain? Tengok rantaian yang paling panjang. So for example, for this one, the longest carbon chain is from left to right kan? 1, 2, 3, 4. Okay, if this one for the longest carbon chain 3, gonna start from here, will be 1, 2, 3. Okay, 1, 2, 3. For example, if you want from this one, I draw from left to right. If you put here 1, 2, 3, still the longest carbon chain is 3. Okay, so this is for C₄H₁. Again, that is what is meant by isomer, where it have the same molecular formula. Okay, this is the name of the molecular formula, but different in the order of arrangement of atom. Okay, for this one, the longest carbon chain is 4. This one, the longest carbon chain is 3. Even though it have different longest carbon chain, but it still follows the same general formula or molecular formula, C₄H₁. Okay, but then the difference between these two is actually this one I draw it, this history here, I draw it in terms of condensed. This one is in terms of expanded structure. Both is fine. So here I'm just going to show it in terms of where it has a mixture of expanded and condensed. For example B, we have C₅H₂. So again, we're going to draw the longest carbon chain. In this case, the longest carbon chain depends on how many carbon present. Example A, we have 4. So that's why the longest one is 4. For the C₅H₂, the longest one, the first possible is if the carbon is 5. Okay, so let us draw if we have 5 carbon. Okay, longest carbon chain, rantaian carbon yang paling panjang is 5. Okay, and then we're going to make sure that each carbon have 4 bond and attached to hydrogen. Okay, next we're going to draw the longest carbon chain. Again, the maximum -1, which is 4. Okay, so we're going to draw 4 carbon. 1, 2, 3, 4. Okay, but then remember for the 5th carbon, we have 5. We cannot put it here because later on the longest one will be 5. If we put it here as well, the longest one will be 5. Okay, how about I put it here? So the longest carbon chain 1, 2, 3, 4, or 1, 2, 1, 2, 3, 4. Still 4. So this is for the longest carbon chain 4. The carbon could be drawn here. Again, we're going to make sure that each carbon is attached to hydrogen. And remember, for each carbon here has 4 bonds. This carbon having form 4 covalent bond. So it means, so what it is meant by that? It only has 1, so the other 3 is bonded to hydrogen, so it become CH3. Okay, so again for this one, the longest carbon chain is 1, 2, 3, 4. Okay, the first one is 1, 2, 3, 4, 5. Okay, so this is the longest carbon chain for 4. Okay, for example, if I put it carbon, okay, 1, 2, 3, 4. If I put carbon here, at carbon number 3 here, okay, if you count it from the left, it will be 1, 2, 3, 4. So carbon number 2, so it's still the same. Okay, so that is for the longest carbon chain, which is 4. So next we're going to try one more. Do we have, is it possible for the longest carbon chain, which is, now it's 4. Can it be drawn if the longest carbon chain is 3? Okay. So the longest carbon chain, 1, 2, 3. Okay, still, we want the longest one to be here. 1, 2, 3. Okay, but then we have carbon 5. So where do we put it? Again, we cannot put at the end here because if we put carbon here, then the longest will be 4. The longest chain, rantaian paling panjang dia 4. Tak boleh lah. So where do you put it? Okay, we put it in the middle here. Carbon, another carbon at carbon number 2. Okay, but then here we only have 4 carbon. So where do we put one more? Because again, we have 5 carbon. Again, I cannot put at the end here because then the longest carbon chain will be 4. If I put it here pun still the same. It will be 1, 2, 1, 2, 3, 4. Okay, so where do we put it? We're going to put it still on the carbon number 2, but then we're going to put it downwards pula. Carbon. Okay, so this is the complete carbon 1, 2, 3, 4, 5, C5. Then we're going to complete our H. Okay, for this carbon in the middle, it's already have 4 covalent bond. Carbon number 1, carbon number 3. We still need 3 more. Okay, this carbon only have 1 covalent bond. So it means that it needs 3 more CH3 here, CH3 down here. Okay, so this is when the longest carbon chain is equal to 3. Okay, so again, isomer, it means that it have the same molecular formula but different order of arrangement of atom. C₅H₁, longest carbon chain 5 is this one. 4, it has different arrangement here, and longest carbon chain 3, okay, we have different arrangement, but then all follows the molecular formula C₅H₁. Okay, so that is for example B. Okay, the longest one we can have 3 only, because if we have 2, for example 1, 2, if you're going to put 3 here and then 4 here, still 1, 2, 3, 4. Still the longest carbon chain is 4. So there's no longest carbon chain 2. Okay, so the shortest longest carbon chain kita dalam kes ni is actually 3. Okay, so that is for C₅H₁. Okay, next we're going to try with C₃H₁. For the first one, the longest carbon chain, again, based on the maximum number carbon present, it's 6. So we're going to draw 6 carbon, okay, straight chain, 1, 2, 3, 4, 5, 6. And then make sure all of it attached to, each of the carbon have 4 covalent bond attached to hydrogen. So this is when the longest carbon chain is 6. Next, we're going to draw when the longest carbon chain, 6 minus 1, which is 5. 1, 2, 3, 4, 5. Okay, so 5 again, make sure each carbon. Okay, 1, 2, 3, 4, 5. Again, this is the longest one. We cannot add carbon at number 1 and number 5. So we're going to add carbon number 2. Okay, make sure that each carbon have 4 covalent bond attached to hydrogen. This carbon, okay, since it only has 1 covalent bond, means that it is bonded to CH3. Okay, so this is the first possibility if the longest carbon chain is equal to 5. Okay, actually we can have 1 more when the longest carbon chain is 5. Okay, so how do we draw it? Okay, again, still 5 carbon, the longest one. Okay, but then, okay, previously we put in 1 more carbon at carbon number 2. But if we put carbon number 3 in the middle here, it will be a different isomer. So we can put it here, the other carbon. Okay, and then make sure that each carbon has 4 covalent bond, which is bonded to hydrogen. Again, don't forget this carbon only have 1 covalent bond, so it needs 3 more hydrogen. So it's a different structure, because when we for the first one, the carbon number 2 that have CH3, but then for the second structure here, the carbon number 3 that have the CH3. Okay, if we put the carbon or the CH3 here on carbon number 4, is it a different isomer or is it the same? Okay, so let us draw it again. Okay, so from here, it seems that it is an isomer, because this one is carbon number 2, this one is on carbon number 3, and this one is in carbon number 4. But then, if we count it backwards or from right to left, this one is number 1, 2, 3, 4, 5, right? So it means that this carbon is actually on carbon number 2. So this one is actually the same. Okay, if you're a bit confused, later on when during chapter 5, you're going to learn about naming, then it will be clearer to you lah. Okay, again, okay, but then why this structure and this structure is not the same? Because if you count it from this one, 1, 2, 3, 4, 5, okay, and then for this one, 1, 2, 3, 4, 5. Again, this is carbon number 3. If I count it backwards or from right to left, 1, 2, 3, 4, 5. Still number 3 is not on carbon number 2. Okay. This one again, when I count it this structure when I count from right to left. 1, 2, 3, 4, 5. Okay, this number 2 is the same as this one. So this is not the isomer. So I'm just gonna erase this one. So there are 2 isomers when the longest carbon chain is 5. Okay. Next one we're going to look at when the longest carbon chain is equal to 4, because this one minus 1. Okay. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so we cannot put the carbon number 5 and 6 at the end here. So first possibility is we put first carbon on carbon number 2 and then carbon number 3. Carbon number 2, carbon number 3. Okay, so again, this one will be CH3, CH3. So another carbon must have 4 covalent bond attached to hydrogen. So this is the first possibility where carbon, the longest carbon chain is 4, but then on carbon number 2 and carbon number 3 have each CH3 attached to it. Hence, it will have C₃H₁. Okay, but then what is the next possibility? Okay, the next possibility is again we have 4 carbon. But this time around, I'll put CH3 both on carbon number 2. Okay, so this 2 is actually a different one because here on the first possibility is that carbon number 2 and carbon number 3 each have CH3 present on the carbon. But this one is that only CH3 is only attached to carbon number 2 here. So again, make sure all the carbon have 4 covalent bond. Okay, so if you put the CH3 1, 2, 3, 4, if you put both of the carbon here, it's still on carbon number 2. Okay, this one is carbon number 2 because when we count from the left, this one is carbon number 2 when we count from the right. Okay, so this is when the longest carbon chain is equal to 4. Okay, so let us try. Is it possible if we have the longest carbon chain is equal to 3? So when the longest carbon chain is 3, 1, 2, 3, and then we're just going to label 1, 2, 3 here. Okay, so again, we cannot put carbon at the end here at number 1, number 3 because later on the longest carbon chain will be 4. Okay, so the possibility that we can have is actually in the middle ni je lah. Carbon number 4, carbon number 5. Okay, so here we have 5 carbon including in the middle. Okay, but then the longest carbon chain is 3. Again, when you count straightforward here, 3, here, 1, 2, 3. If you count from here pun 1, 2, 3. Okay, but then remember this is C₃H₁. So where we put the carbon? Where do we put one more carbon? We cannot put it here because later on longest carbon chain will be 4. So cannot lah. Okay, if you put carbon here pun sama juga. The longest carbon chain here will be 4. If you put longest carbon chain here, we're going to add here pun sama juga. 1, 2, 3, 4. Okay, we cannot put in the middle here, carbon here, because maximum number of carbon is only 4 bond. Okay, so there is no possibility when longest carbon chain is equal to 3. So we're just gonna erase it. So for C₃H₁, okay, the longest carbon chain, the minimum number for the longest carbon chain is 4 lah, cannot 3. Okay, so this is all the possible isomer for C₃H₁. Again, we're going to start with the longest carbon chain with the maximum number based on the molecular formula, and then we're going to try -1, -1, -1, where there is possible. Okay, again, if you're a bit unsure, when you draw the longest carbon chain, label the carbon by the number itself. Okay, so isomer, it means that, again, it has the same molecular formula but different arrangement. So that is the example for chain isomerism. The second type of constitutional isomerism is positional isomer. Okay, so here positional isomer have same carbon skeleton and same homologous series. Carbon skeleton means that it all have the same longest carbon chain. Okay, but what it actually differ? It differ in position of the functional group. Okay, so let us look for example A here. Example A, C₃H₁, Cl. So Cl is our functional group, which is halogen. Okay, so when we draw it, again, it have the same carbon skeleton. So first I'm going to draw with carbon, we have 3. 1, 2, 3. Okay, and then each carbon have 4 covalent bond. But then we have functional group here is Cl. So first possibility, I'm going to put Cl on carbon number 1. So this is the first possibility. Again, for positional isomer, it differs in position of the functional group. So for the second possibility, I'm still going to draw carbon. The longest carbon chain is still 3. And each carbon have 4 bonds. But this case, I'm going to put the Cl on carbon number 2. Because actually, again, the difference is the position of the functional group. So this one is different. So here on carbon number 1, here on carbon number 2. Carbon number 2. So, okay, and then we're going to complete it with hydrogen. So this is the possible isomer in terms of positional isomer. Positional isomer have the same carbon skeleton, still 3, but then the difference is that position of the functional group. So here is carbon number 1, here is on carbon number 2. If I put on carbon number 3, 1, 2, 3, carbon Cl. Okay, if I count from left to right, it will be 1, 2, 3. But if I count from right to left, it will be 1, 2, 3. So 1, 2, 3, it means that carbon Cl on number 1 is the same as the first drawing here. So this is the possibility for C₃H₁Cl. Okay. Next, we're going to look for C₅H₁OH, where we have alcohol. The functional group is hydroxyl. Still, the longest carbon chain is 5. 1, 2, 3, 4, 5. Okay, so here 1, 2, 3, 4, 5. Okay, so for each carbon needs 4 bonds. Here, I'm just going to put OH on carbon number 1. Okay, again, make sure that the carbon attached to oxygen. Okay, not the hydrogen, the carbon attached to oxygen. Okay, so the rest will fill in with H. So this is the first possibility. The second possibility, again, we still have the same longest carbon chain, but the difference is that the position of functional group. So previously we put it in number 1. Now we're going to put it on number 2. So again, make sure that carbon attached to oxygen. Okay, and then we're going to finish up with hydrogen. This is the second possibility. So is there any more possibility for the difference in the position of functional group? Yes, we can put the OH on carbon number 3. Okay, so we put it again, carbon attached to oxygen and hydrogen. Okay, and we fill up with H. Okay, so for C₅H₁OH, there are 3 possibilities where the difference is that the carbon chain is still the same. This is not chain isomer, this is positional isomer, because the difference is that the position of functional group, which is the OH, is hydroxyl. Okay, next we're going to look for C₄H₄. C₄H₄ is alkene. It's not alkane because alkene C₄H₁. So alkene means that we have double bond between carbon and carbon. So we have 4 carbon. 1, 2, 3, 4. Okay, I'm just going to label it. Okay, so first possibility is that the double bond is between carbon number 1, carbon number 2. Okay, for this one, make sure that each carbon only have 4 covalent bonds. This carbon already have 2 bonds, so it needs 2 more. This carbon already have 1, 2, 3, so it needs 1 more. Okay, this one only have 2, so it needs 2 more. And then carbon number 4 only have 1 covalent bond, so it needs 3 more. Okay, and then we're going to fill up with H. This is the first possibility. Okay, so for the second possibility, it is between number 2 and number 3. So here, okay. And then make sure that for each carbon only form 4 covalent bond. So be careful, especially because we have double bond here. Count it as 1, 2. Okay, so this carbon only have 1 bond. This carbon already have 1, 2, 3, so it needs 1 more. The same goes for carbon number 3. Carbon number 4 only have 1. Okay, and then we complete it with H. Again, for the positional isomer, the longest carbon chain is still the same, but the difference is that the position of the functional group. In this case, functional group is carbon-carbon double bond. Okay, again, isomer means that we have the same molecular formula but different arrangement. For example, for the first possibility, double bond between number 1 and 2. The second possibility between carbon number 2, and 3. Again, why I didn't draw the double bond between 3 and 4? Because if between 3 and 4 here, 1, 2, 3, 4. Okay, I'll put 3, 4 here. If I count it from the right, it will be 1, 2, 3, 4. So double bond is between 1 and 2, the same as this one. So that is for positional isomerism. The third and the last part of constitutional isomerism that we're going to learn is functional group isomerism. Functional group isomers have the same molecular formula but different functional group and homologous series. So first, let us look for the case of A for alcohol and ether. Alcohol and ether follows the same molecular formula or general formula, which is CnH2n plus 2O. So for the alcohol, it means that the carbon containing OH, whereas for the ether, it does not contain OH. It means that the oxygen is in between two of the carbon. So first, let us look for the case of C₂H₁₀. Okay, for the alcohol, it means that we have two carbon and the carbon is attached to OH. Okay, so this is the homologous series or the functional group. Okay, so again, make sure remember that carbon needs 4 covalent bond and is bonded to the hydrogen. For ether, we have oxygen in between the carbon. So first we're going to draw COC. Okay, but since we have only two carbon and the carbon it has been used, which is attached to oxygen, so it means that now we're going to complete the carbon with 4 covalent bond, which is bonded to the hydrogen. So again, when you look here, for the alcohol, we have C2H, we have 6, and we have O. The same goes for this ether. We have C2H, we have 6, and then O. Okay, again, isomer means that we have the same molecular formula but different arrangement, different way of how the atom connect to each other. Okay, for the case of alcohol, okay, the partner is ether, which follows CnH2n plus 2O. Next, we're going to look at for the functional group or the homologous series of alkene and cycloalkane. It follows the general formula of CnH2n. So alkene means that we have double bond between the carbon. So let us look here. We have C₃H₁, means that we have 3 carbon. And then we have to show there is one single bond between the carbon. So again, we have 3 carbon here. So you can put the double bond in between 1 or 2 or 2 and 3. So I'm just going to put double bond here. Okay, and then make sure that each carbon have 4 bonds or 4 covalent bond, which is bonded to hydrogen. So this is for the case of alkene of C₃H₁. Okay, how about cycloalkane? So alkene means that it has no double bond, it only contains single bond. But then cyclo means it is a cyclic structure. So since carbon is 3, so we cannot put it in cyclic in a circle or in a square. Because the square means that we have 4 carbon. If it's 3, means that it is in a triangle. 2, 3. Okay. Then remember, each carbon needs 4 covalent bond, which in this case it will be bonded to the hydrogen. Okay, so this alkene and this cycloalkane follows the same molecular formula, which is C3. We have 3 carbon here, and we have H6, which is 1, 2, 3, 4, 5, 6. This one, 1, 2, 3, 4, 5, 6. Okay, so for the partner of alkene, it is cycloalkane, which follows CnH2n. Next is the partner of aldehyde and ketone, which follows CnH2nO. So for the aldehyde and ketone, so aldehyde means that we have C double bond O attaching to hydrogen. Okay, in this case of ketone, it is C double bond O attached to R, means any of the carbon. So I'm just going to label. R means that we have any carbon. So first we're going to look at for the case of aldehyde, C double bond OH. Okay, so we have used one C, but then for this case we have C3. So it means that we need 2 more of the carbon. And then now we're going to complete this carbon, okay, with 4 covalent bond. Okay, this carbon already have 4 covalent bond. 1, 2, 3, 4. So you're going to complete the 4 covalent bond for these 2 carbon. So this is for aldehyde, where we have C double bond O with H. Okay, what about ketone? Ketone still have C double bond O, but it must be connected to 2 carbon on the right and on the left. So based on this general formula, or the molecular formula here is C3. So it means that we already have 1, 2, 3. So now we're going to complete the carbon with 4 covalent bond. So as we can see, these two, aldehyde and ketone, we have C double bond O, but then the difference is that the aldehyde must be attached to 1 hydrogen, but then for the ketone, C double bond O must be attached to 2 carbon, okay, which follows the general formula of CnH2nO. Last but not least, we're going to look for the case of carboxylic and ester, which follows the general formula CnH2nO2. Okay, for the case of carboxylic acid, it has C double bond O and O attached to hydrogen. So we're going to start with this one first. And then, as we can see, we have used 1 carbon. So here we have 3. So we're going to complete it with another 2 of the carbon. And make sure each carbon contains 4 covalent bond. This carbon already have 1, 2, 3, 4. But then there's 2 carbon, okay, haven't formed 4 covalent bond yet. So this is for the case of carboxylic acid. How about ester? Ester is that C double bond O attached to O and oxygen is attached to another carbon. Okay, and then the C double bond O also attached to another carbon. Okay, and then we check here, we have 3 carbon and this one also have 1, 2, 3. And then check that for each carbon already have 4 covalent bond. If it haven't already have 4 covalent bond, then we're going to complete it with carbon-hydrogen bond. So this is for the case of carboxylic and ester. Okay, for these two, it contains C₃H₁₀. Just please add in your notes, for the case of carbon, carbon needs 4 bond, okay, 4 covalent bond. So it could be either single, double or triple. Whereas for oxygen, it needs only 2 covalent bonds. So it's either single or double. Okay, so why do we have to write this down? Again, when you look for the case of aldehyde and ketone, the C here has 4 bonds, but the oxygen only needs 2. The same goes for the ketone here, C double bond O. So oxygen needs only 2. Okay, so why? Because actually there's a lone pair present. Okay, when the lone pair present, when we calculate the formal charge, okay, the oxygen will have 0 due to the presence of bonding pair ataupun the number of bond and the lone pair itself. The same goes for carboxylic and ester. We have 2 oxygen here. This oxygen, okay, have 2 bond, okay, 1, 2. Even though it has 1 double bond, but actually it has 2 covalent bond. The same goes for oxygen here. It has 2 covalent bond. Okay, the same goes for the ester. So that is for the functional group isomerism. For the functional group isomerism, you must refer to the number of carbon, hydrogen and oxygen or the molecular formula and then check whether it follows this one, A, B, C or D. Okay, and then this one you have to memorize itself lah. If the general formula is this one, the partner will be alcohol ether. This one is for alkene and cycloalkane, CnH2nO, aldehyde and ketone. Where if we have 2 oxygen, so it means that it will be carboxylic and ester. So in this video, you have learned all about the constitutional or structural isomerism, where chain isomer it is differ in carbon chain, positional isomerism differ in position of functional group, where the functional group isomerism itself, it will have different functional group or homologous series. Okay, so that is all for this video.